What's a 0? Aaron, what's a 0? X-intercept. What's another name for it? Evan.
Root?
Yep, I'll take that. The root, the 0, the x-intercept, okay? And your zeros or roots can be either real or they can be imaginary. Okay, everything we've been doing so far are all real. Then it's in the real number system. Okay? A root in the imaginary root is a root in the complex number system. And it does not cross the x-axis. And it's in the form of a plus bi. Remember all that stuff? Alrighty. Functions of odd degrees. Okay, some rules about that. If you have a function of odd degree, so it's like x cubed, alright, it must cross the x-axis at least one time. Okay, so that means there is one real root, such as x is equal to 2, whichever one. And remember when we were talking about the end behavior, your end behavior was where it went like up, which would look like this, something like that. Functions of odd degree are always either up and down or down and up. Okay, so your up and down is when you have the positive, so like a positive x cubed where it's coming up, and then what am I doing? Up and down, and then down and up. I can't draw this morning. So that one's would be the negative, and that would be like a positive. Does that ring bells? Sure, yes, we remember all of this, don't we? Love it. All right, functions of even degree. Okay, they cross the x-axis at most the nth degree. Okay, so if I have like x squared, then I'm going to have 2 roots. If I have x to the 4th, I'm going to have 4 roots. Or not at all, which means you have imaginary roots. So in other words, if you have an odd function or odd-degree function, then you're not going to have the imaginary. You know you're going to be crossing for sure. All right? Your even degree and behavior is always up, up, if it's positive, or down, down, if it's negative. So like negative x squared. Good? Ready to roll on? Ready, Lydia? All right, let's do it to it. Okay, we have what's called the remainder theorem. Okay, and basically what it says is that if you divide by x minus c, then your remainder is going to be the result of substituting it in. So in other words, you can use the theorem to find the remainder instead of long division, since I know how much you love long division. So, if we want to find the remainder of f of x is equal to x cubed minus 4x squared minus 5, if it's divided by x minus 3, we don't want to have to go through all the long division. Then we can just say, hey, well, that's like saying my root to x equals 3. So, I substitute 3 into my equation. And so I would have 3 cubed minus 4 times 3 squared minus 5. So when I simplify, I'm going to get 27. 3 squared is 9. 9 times 4 is 36. And when I plug and chug that in the calculator, I get negative 14. So that means my remainder for x minus 3 is going to equal negative 14. Good? Okay, so do we ever care about what a remainder is on a polynomial? No, we don't really care. However, when we do care is when we're talking about the factor theorem, okay? The factor theorem says that if you use your remainder theorem or do your long division and you get a remainder of 0, then it is a factor of that particular polynomial. So instead of doing your slide and divide and all that other stuff, you can use the remainder theorem to see if it is a factor. Okay, so it's another tool to use. So basically what it says is we say, okay, well, if it's a factor, then that would mean x is equal to 1, right? So let's find what the f of 1 is. So I'm going to have 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. So that gives me 2 minus 1 plus 2 minus 3. And plug and chug, I get 0. Since my remainder is 0, then x minus 1 is a factor. Okay? Which is a whole lot easier than to try and divide out and all that other stuff. Make sense? Easy peasy? Sure. It's quiet today. Alright, so how many of you remember synthetic division? Okay. Synthetic division is another way to see if you, instead of substituting it in, you can use synthetic division to, here, I'll use red. Okay, to see if there's a remainder. If there's a remainder, then it's not a factor. If there's a remainder of 0, then it is a factor. So, synthetic division, we're going to set and find that x is equal to -3, because if it's a root, then it's going to be -3. Agreed? All right. So we could do like what we just did and simplify it out and all that stuff. Or we can use the synthetic division and say, okay, I have all my coefficients, 2, -1, 2, -3. And so the first step is to bring the first coefficient down. So I bring my 2 down. Anybody remember what you do next? Yep, multiply -3 times 2, which gives me -6. Okay, then I'm going to add my 2 numbers, so -1 plus -6 is -7. Okay, so now rinse and repeat. -3 times -7 is 21. Add those 2 together and get 23. -3 times 23 gives me -69. And so when I add those together, I get -72. So I have a remainder. Oops, can't spell. So x plus 3 is not a factor. Okay, which one do you like better? Synthetic division or where you substitute it in? Either one works, okay? This is you use whichever one you like better, all right? Bottom line is it doesn't matter. 2 methods to kill the same bird, okay? All right.